Hello and welcome everyone to today's webinar, Introducing KubeCarrier, Operating Services the Cloud-Native Way. My name is Christine from Kubernetes. I'm together with my colleagues Sebastian and Nico, who will be speaking today. And today we will present you our brand new open source project, KubeCarrier, which internally we also like to call the operator of operators, because it leverages Kubernetes operators to operate services across multi-cloud and multi-cluster. If you have questions during the presentation, then just please type them into the chat window so we can either answer them straight away or in the Q&A session after the presentation. And in case you need to drop out early, no worries. We are recording this webinar and will share it with you in the coming days. And with this, I already want to hand over to Sebastian, our CEO, and Nico Shida, who is the core contributor to the KubeCarrier project.
Yeah, hello and welcome to this webinar, and great that you had the time to join us. So let's talk about KubeCarrier and why we started this project, and also what we want to do with this project, and where we think KubeCarrier can help to solve some problems on a daily basis. So what we're seeing now more and more adapting like multi-cloud or on-premise environments and Kubernetes is not enough. It gets more and more challenges. Like everyone is now talking about multi-cloud and hybrid cloud. Now a lot of people seeing all this complexity about cloud, hybrid cloud, on-premise deployment, and start using Kubernetes to do this. And what we're seeing, there's also a trend to having more and more smaller clusters across different environments. But also one of the challenges is like if I have different teams, how do I provide then my application or my service I'm building either internal to my organization or external to my organization as a service? So like imagine in the old days, you want to get a service, or you want to get access to or set up a new database. Typically the process was you need to create a ticket, you need to send an email, and then someone is doing something and provide you with a feedback that something is setting up. But now we want to provide much more a self-service driven way to do this, like with the cloud providers coming up, also the way like we're working now in new environments, like really self-driven, completely automated environments, and like each team can individually decide, okay, now it's the time to create a new service, destroy a new service, and also providing different kinds of application as a service, either inside the organization or to external as a service. And so what we are thinking there is like Kubernetes can help to deliver, or a cloud native application can help this to really solve this problem in a really smart way. Because if you're looking into how a problem is described, it's really like the gap between what it is and what it should be. And especially like Kubernetes with this reconciling approach, like where you have an actual state and a desire state, and Kubernetes every time comparing if your existing application is mapping with your actual state, can help a lot. We see now more and more the operator pattern is coming up, where people using this pattern to deploy more stateful applications or more complex applications, but how can others consume this pattern? Like how can others consume inside your organization or to external this in a centralized way, so that different teams can building operators for their application, what they're building, and others are capable to use this operators or use these services. So for example, calling an API to spin up a new database, and potentially not even get access to the cluster where the database is running on, really like getting it exposed via an endpoint, and you get the access credentials, and then you can use it. And that's the reason why we're thinking we need a new tool to do this, like a centralized way, how you manage application in a centralized way, to manage application scalable, and also to, if now everyone is building operators, to have it in a centralized way, how you provide this in a service hub to your organization. And now I want to hand over to Nico, who will give you more details and more examples how this works.
Hello, everyone. Thanks for the start, Sebastian. So I will now go through the features and what our product vision for KubeCarrier is, and tell you how to actually get started with it. So the main thing we want to build is a central service hub. So one of the big things that we see more and more is it's easy now with Kubernetes to actually deploy applications. You have operators, you have Helm charts. It's easy to get stuff running. But how do you provide those services to people? How can you make it accessible in a service catalog? So you just want to give people the option to, hey, I want this thing, click, click, done, right? Currently, most of these processes are still done via Jira or ticket systems via email, and it's kind of clunky and takes away a lot of the fun. So the first big thing is the service catalog, the service hub, which is a central place where you can store and discover all the different services that are available across your platform. So you can have multiple different Kubernetes clusters. In this case, we have EU West 1 and US East. Those have different operators installed for PostgreSQL, for Redis, for MariaDB. And all of those different services, these different operators, can be pulled together into one central service hub, service catalog. All of this is driven via custom resource definitions. So there is no custom integration needed. KubeCarrier will discover custom resource definitions that are available on those clusters, which is automatically the case when you install an operator, and make them available for management and distribution in this self-service catalog. And the cool thing is, on top of that, we provide day two operations. So it's not like a Google Marketplace, for example, where you install and kickstart a certain tech stack. You have the ability to later upgrade, change, and drive those installed instances. Next slide, please. Need to remote control Sebastian a little bit here. Yeah, multi-tenancy. So just having a central place to discover your services is not enough. You want to be able to actually slice this into different user groups that can consume your services. So there's another big thing that we're currently building into our products is how can you manage multi-tenancy in this environment? You have different teams, different stakeholders that you want to give different set of permission to access these services that you have in your service catalog. So for example, the front-end team gets access to just Redis databases, while the API team, the application developers, they get full access to everything you have. And maybe you can even give direct access of your customers on the platform to create some databases as a service. So you can use the same mechanism and underlying infrastructure also for external businesses. And all of this is driven natively via custom resource definitions, quotas, and, well, namespace isolation. Next slide. And to really drive this home, the only thing KubeCarrier does is you point it at a custom resource definition somewhere else, TM. It will discover this custom resource definition and make it available in this multi-tenancy environment. So instead of having to take care of all the details, or adapters, whatever, you could just say, I have this operator here, it's already running fine, and now I want to have additional management capabilities on top. Okay, now to make this a little bit more concrete, we have a few UI mockups that show this marketplace in a little bit more practical form. So the interesting part is we have this central service catalog where you can discover stuff, obviously filtered by provider and regions. And that's without you having to build your own solution to actually drive this. All of this is then included in KubeCarrier. Next slide. And to actually create services, because they are like completely dynamic, we're currently relying on specifying the YAML. So we can pre-fill this via the schema of the objects that is known to us. That's described in the custom resource definition. But this already allows people to discover and quickly iterate on these services. Okay, so far to the UI. Let's actually dive a little bit deeper about and look how stuff works together on a high level view. There are a lot of things here. To start, top left, we have the operator deployments in what we call a service cluster. So service clusters are what we think software as a service workload should be deployed to. So it's a cluster in control of the service provider or a sub-team of the service provider, and it's distinctly separated from the end user, which enables you to drive SLAs and restricted access control. Because in the end, all the user wants to know is how can I connect to it, what are my credentials, and how can I use this service, how the service is operated, how the uptime is taken care of and monitoring. I don't actually care in this case. So on the service cluster, we have the operator deployments that actually drive and operate the workload. And then for every end user, which is kind of dynamic, we create a workspace, which is just a Kubernetes namespace. And you can then set up your network isolation and whatnot to drive full isolation of these namespaces. And in there, we will put the application instances that the user creates. And this doesn't need to be a real application instance. This can be any CRD instance. So you can have like a database operator, you can have your own RESTful API, WordPress, or even control network appliances, depending on the operator and the cloud environment that you're running on. And on the service cluster level, it's also where the network ingress to those things that you deploy and the storage is taken care of, which is something that KubeCarrier itself does not help with, but it helps you actually distribute connection information, right? And then on the central KubeCarrier cluster, the central KubeCarrier control plane, we have multiple provider accounts, multiple tenant accounts, and what falls into the platform operator responsibility. So you don't only have to support a single provider, but you can also have the central KubeCarrier installation in your organization and have different departments share services. So to come back to our kind of boring database example, you can have one department that takes care of databases as a service, because databases are hard. Storage is hard. That's something you want experts handling. While other teams can offer extra APIs that other teams can use and utilize. And this makes it discoverable what instances, how your whole architecture looks like later, right? Because you have this service catalog, those shared services, and you get rid of duplications. Not every team needs to take care of actually hosting, managing, and backing up this database. You can just consume it from a department that knows how to actually do this. And this, each provider can have its, can separately control which service clusters are registered for their provider account and control how they manage their catalog. And they can even be a tenant of either other providers on the same platform. So you can provide like value add services by providing Postgres, WordPress, for example, on top of an existing MariaDB service from someone else. While the tenants can see and discover the catalog of services and just do the instance management. So if one provider is sharing services then to this tenant, they can then immediately create those instances and start to consume the service. And on the far right, we have the platform operator, which is in charge of the KubeCarrier operation. So how does KubeCarrier itself work and operate? And the overall account management, which can also be automated on your platform by integrating with like a sign-up UI, for example, right? And underneath, like lower levels where this all can operate on is obviously our Kubernetes platform that we open sourced not long ago to actually create clusters on multiple cloud providers. But KubeCarrier is explicitly designed so it does not care which kind of Kubernetes cluster you're using. You can use Kubernetes, you can use Google Cloud Platform and GKE, or any other cloud provider's flavor of Kubernetes. You can also use Kind, Minikube, or whatever to test out those systems. And the installation is super straightforward, but we will come to that. Okay. Next, a little bit configuration. How do you actually set up something so you can get started with it? Next slide, please. Perfect. So don't worry, it all makes sense soon. This is the most top-level configuration objects that we have in KubeCarrier, just as an overview to get you started with it. So on the left, we first have the an overview about how things match together. So for each provider account, first thing you would do is you would upload a kubeconfig secret that is allowing KubeCarrier to connect to this remote cluster and fetch information and connect to it with this service cluster object. And the service cluster object itself will do, like the controllers that run behind it will do some basic uptime checking, discover information about this remote cluster, and so on. And now the cool part is this catalog entry set. And I will show or point you to examples later on. This catalog entry set, the only thing you need to specify here is on which clusters do I want to search and what custom resource definition do I want to have in my catalog entry. And then KubeCarrier will search on all connected service clusters that you specify, whether this custom resource definition is registered, pull in this information into our central catalog, and allow you to create and manage instances of this custom resource definitions from our central control plane, and share these services and the right to create those instances on this central platform. And then in the consumer, in the tenant accounts, you can discover what is available to you via offering, region, and provider objects to get to see, hey, what can I do on the platform at the moment? How do these schemas look like? And then they can create instances of those services. To make this a little bit less abstract, on the right is the same diagram, but with an example. So I have a service cluster, EU West 1. On EU West 1, I have a CouchDB operator. So I tell KubeCarrier, hey, there's a CouchDB custom resource definition there, get it into my central catalog. I share this catalog with everyone on the platform. Then I have this namespace custom resource definition, couchdb.eust1.kubernetes, which Kubernetes is this provider's account. And in the tenant account, I can discover the offering couchdb.eust.kubernetes, which is in the region EUWest1, and from the provider Kubernetes, right? And then I can create my my instances from this definition that is shared to me. Yeah, and to get started with it and get your hands dirty, we have, when you go to the next slide, I hope this shows the link now. For getting started, we have updated our documentation and have a complete getting started guide. The nice thing is the only thing you need is Kubernetes in Docker kind and our little released binary, which is a kubectl plugin. And then install cert manager on the central cluster and say kubectl KubeCarrier setup. And you will have your own little KubeCarrier master cluster. Yeah. That's about the overview at the moment.
Exactly. So we were thinking we're giving you a more detailed overview. In the next webinars, we will also really get hands-on and yeah, show you how to install and what to do with KubeCarrier. But we were thinking it's important to get first the overview and understanding about the concepts. And so if you don't want to wait until the next time, yeah, here you can see the link or docs.kubernetes.com/KubeCarrier. You will find our documentation and there you can set it up. And yeah, now I would hand it over to Chrissy if there are any questions.
Yeah, thank you all for joining, and Nico and Sebastian for presenting. Are there any questions? All right, it does not seem to be as if there are any questions. Yeah, Bob is asking, which services do you support today? Nico, can you answer that?
So we're currently heavily testing all different kinds of operators. At the moment, we found out there's a small compatibility problem with V1 Beta 1 in some cases, but we support like everything. As soon as you have an operator that works with custom resource definitions, and I have not found a single one that doesn't, you can plug it into KubeCarrier.
Yeah, and I think here it's important where we could also get your support. So if you see things which are not working, please feel free to create an issue so that we can look into this and fix this, because the main idea of KubeCarrier is we want to build a generic way how to manage this, and it should not be specific to any kind of operator. It should be generic for all kind of operator which are based on CIDs, so that we can use this or can help you to manage and deploy the specific services of the operator.
Do we support OpenShift as well?
So OpenShift has a normal compliant Kubernetes API, so I don't see any reason why, but we have not tried it out yet. It's kind of hard to get a hold of a nice OpenShift installation.
Nico, one question. What's the minimum version of Kubernetes you need to have?
Let me double check. 1.16.
Yes, so it should work with all Kubernetes distribution which support Kubernetes 1.16, which is already available in OpenShift. So with this onwards, it should work. But until now, we have our test running on purely Kubernetes. But looking into extending this in the future as well.
Any more questions? All right, then let's jump to the last slide. Yeah, thanks again for joining. Today's the first KubeCon virtual started, and we are of course there as a sponsor as well. So if you are at KubeCon virtual, please pass by our booths. We are in Startup Hall A. Also, if you do not have a voucher for KubeCon yet and you want to visit our booth and check out KubeCon, please write me an email at marketing@kubernetes.com, because we have a couple of vouchers left that I am happy to share. Also, we are always very happy about people who follow us on Twitter at kubernetes.com or give us some stars for our projects on GitHub Kubernetes/Kubernetes. And with this, I want to end today's session. And yeah, I hope to see you either at KubeCon or at one of our upcoming webinars that you can find on our website, of course. All right, so I wish you all a very nice day, and yeah, hopefully see you soon. Bye.
Bye.